over here, and this is the 1999 AIME problem number 9. And here's a view of this problem. A function f is defined on the complex numbers by f of z is equal to a plus biz, where a and b are positive numbers. This function has a property that the image of each point in the complex plane is equidistant from that point and the origin, given that the modulus of a plus bi is equal to 8, and we wish to find b squared. Okay, so first let me just write this function down. So f of z is equal to a plus b I z, right? So now let's get a geometric interpretation of what this function is actually really doing. Okay, so let me just draw this Cartesian diagram over here. So given that some point over here, this function will take us to some point over here, such that if we draw these distance lines, these lines will be equal, right? Just the function has the property that the image of each point in the complex plane is equidistant from that point and the origin. So the original point will be z. The function takes it to a plus bi z, right? And then this is obviously just 0. Okay, so now let's just use the property. It says that they are equidistant, meaning that the distance is the same. So let's just write this as a plus bi z minus this. The modulus of this will simply equal the modulus of a plus bi z. Okay, now let's do some more work. Let's factor out a modulus of z, both sides. This becomes modulus a minus 1 plus bi, and then this is equal to modulus of z times the modulus of a plus bi. And that just follows that the modulus of the product of two complex numbers is equal to the modulus of each complex number, and I'll leave the proof as an exercise for you guys. Okay, now we can safely cancel modulus of z, because if the modulus of z is equal to 0, then z must be equal to 0, and if z is equal to 0, this function just degenerates into a single point 0, 0. So we can safely cancel the absolute value of z to get a minus 1 plus bi is equal to a plus bi. Okay, and then now writing this out like in words, just move my pad, is equal to a squared minus 2a plus 1 plus b squared is simply equal to a squared plus b squared, just taking the modulus and squaring. Now we can cancel a squares and b squares, and solving gives us a is equal to 1/2. That's great. Now we have a is equal to 1/2, and we can easily find b squared, but just so we know the complex numbers of the form 1/2 plus bi, and we know this modulus will be equal to 8. So therefore, if we square this to 1/4 plus b squared, this gives us 64. And then solving gives us b squared is equal to 256 minus 1 is 255 over 4. We have solved for b squared. They are relatively prime and they are positive, so our answer is 259. And we are done.